Hi everyone and welcome to this quick tutorial on piled wall systems utilising Autodesk Revit and Dynamo. So you can see here we have a fairly simple model. What we're really interested in though is this topo surface here. And what I want to do is define a path for my sheet piling and then get it to follow that path and in the context of the levels on my topo surface. So I'm going to start off by creating my path. So in this example, I'll switch into the site plan view here. I'm going to use a model line. So here's model line. And what I want to do is really demonstrate the productivity benefits of using Dynamo. So I'm deliberately going to add in quite a few curves here as well. So we'll have some sheet piling coming down here. I want to now have a curve starting. So in this example, I'll use a tangent curve here. Perhaps we'll take the curve around over here and then we'll need to retain some earth up this way and just across there. So there's my path that I want to populate with sheet piling. Okay, so let's now switch into the 3D view and we can now see that path clearly shown just above the topo. So it's now time to start up Dynamo. So if you're using older versions of Revit, in this example I'm using Revit 2017, and older versions of Revit, Dynamo will appear on the add-ins ribbon. On 2017, it would appear on the manage ribbon. So let's start up Dynamo. Notice you will need Dynamo for Revit here as well, and not Dynamo for Studio or Dynamo Studio, because you obviously need to be able to connect in with the Revit geometry. So here, we'll create a new graph. Okay, and here's my new graph. What I'm going to do here is just set up a few things. I want to see a preview on my grid in here. And you can see here I'm going to get a background preview, and also I'm going to see a preview inside Revit as well, which is good. Just a couple of things before we start. You can see here that I have a graph view for navigation and also a graph view here for the model itself. So I can just switch between the graph or the model. Okay. So what we need to do is we need to start by being able to select things in Revit. Now the first thing I've got are those model lines. So I'm just going to type into the search box here, select model elements. Yeah. Now you'll notice here that I have model element, which is one object, or elements, which of course is more than one object. So here's my first node. You'll notice it's yellow at the moment. That's because it's still waiting a selection set. So we can now start to manipulate the display in Revit. We'll select those model lines like so, and straight away now you'll see that it comes back with the element IDs of those model lines. What we now need to do is extract the curves from that. So again, I'm going to utilize a search bar, so I want to extract curves from an element, so I can just type in element and then curve. Okay, and you can see in here the curve in this element, or curves in this element. So if I now wire those two together, what we're doing here is we're looking at the data preview window, and you can see here that I now have a list or sub-lists of the line and the four arcs that have come out of the model lines. Okay, and you'll notice in there as well that we have the vectors, the lengths, coordinates, and so on, everything we need. Now, that is a sub-list, as you can see there. I have a list here of 0, which is the index number, and then I have another sub-list underneath. What I want to do is flatten that down. Now, I'm just going to show you another technique here. Rather than typing in everything into the search box here, I can actually use the node library down through here. So if I go to core and then lists in here, or list should I say, you can see now I have all of my tools in here, and here I have flatten. So I can literally just click on that and be able to flatten down that list. Now, I'll plug the list in there, and I want to flatten by one level. Okay, and you can now see that I have a completely flattened list out. Right, so now we have a series of curves. Now, even if it's a line, in Dynamo it's referred to as a curve. Yep, so we have now those 5 curves in the list there. So what I want to do is I want to join those together. So we want to create something called a polycurve, which is a number of curves joined together, and then I want to say joined. Okay, so here's our node. So we now wire that together, and what that does is that gets all of those curves and welds them together into a polycurve. So we've now got a single curve. Finally here, we'll take the another node, which is the curve length, wire that in there, and now we have the total length of all of those curves. Now, of course, the whole thing in Dynamo is of course completely live. So if I start to make some changes to the geometry, let's just turn the data preview window on, and we'll select this here. Yeah, you can see instantly the curve value changed there. Let's put it back into 20 meters. Yeah, and there's a change. So that's the nice thing with Dynamo. It's constantly connected into its application, which in this case is Revit. Okay, that's good. So let's move forward a little bit more. So what we now need to do is start to deal with the topo surface. Now you can see here this says select model elements. The end user might not understand what to do there, so I'm just going to make this a little bit more intuitive. Okay, and we can just say there, select model lines for piling path. Yep, so it makes a bit more sense. Right, so now I need another selection in here. Again, I'll utilise the library for this, so you can see another way of doing this. So we want a selection from Revit, so I can go to the Revit library in here. Here's the selections in here. You can see I have all manner of things I can do. Select faces and select model elements. This time I only want to select one object, which is going to be that one topo. Yep, so select topography. Okay, so let's now make that selection. So that's going to be this topo here. And there we have it. Now, what we need to do is we now need to convert the topography into a surface. So I can just type in topography. That should now bring up a list of the items that I want to search for. And you can see here I've got topography to poly surface. I've got another one here. Both these are by Spring Nodes, which is an add-in package, which is free. Obviously, Dynamo has thousands of add-in packages that you can bring in. This one's developed in Python script, which is a little bit quicker. So I'm going to use this one, and I'm now going to wire that together. And now what my Dynamo preview's now done, hopefully, is now previewed my model lines, which I should see somewhere. There we are, and my topography. Yep, as you can see here. Excellent. Right. So what we now need to do is that the plan is I want to take those model lines and project them down onto the surface. So actually get a three-dimensional kind of path, if you like, which is going to be the path of my piling. Now to do that, I need to basically project onto a surface. So once again, rather than trying to find it in the library, I can just type in project onto surface. Okay, and you can now see here I have this node. So let's have a look at the input. So it needs a surface first. So that's going to be this one here. It also needs the geometry to project onto the surface. That's going to be that single polycurve. And of course now it needs to know the direction. Is it projecting in the X, Y or Z axes? Now that input actually requires a vector. And you can see as I hang over this node here, it's telling me it needs a vector. So let's type in Z-axis, which is actually a vector. Okay, so that's what we want to do. Whoops, I want this one. Now what this node does, you can see it's got no inputs, but it will have an output, which of course is a vector in the Z. So I can just plug that in there. Okay, and now if we start to take a look at the geometry, yeah, we can now see that we have that projection. Now of course, once again, as we've already discussed, if I start to play around with the path, obviously it will update the length of the line there and also the projection. If I change the topo surface, again it will update that path. I'll demonstrate all that once we've got the piling in place. Excellent. So now let's take a look at the output of this. Now it's always very, very useful to actually keep checking outputs to see what we're working with. So I'm just going to take a look at this geometry here. And you can now see I've got a whole bunch of NURBS curves. As you would expect, if I just go into Revit here, just to show you what we've got in the background of Revit, you can now see it's previewing this. And because that topo surface is undulating, of course, it's now generated NURBS curves and lots of them around there. So clearly, I now need to do a very similar thing and actually join all of those curves together using the same node as I did before. Yeah, that's this one here. Now, rather than create that again, I can just copy and paste it and then wire the geometry output to the input of those curves. I don't need the watch window anymore. And hopefully now I have a single polycurve. Now at this point, you'll notice I've been running in automatic mode. I'm going to change it to manual here so I can decide when it actually performs a run. Just going to tidy up my nodes a little bit here as well, just to give us a little bit more space. Okay. Right, so now we're ready for the next bit. What I really want to do now is divide this curve into a number of points. Yeah, and the idea is we're going to put an adaptive family down those points. So, in here, we'll say curve divide. Okay, and you'll see here that I now have this divide curve tool, and we'll put the output of the projection as a polycurve into the curve input there. And basically now I now need to create the number of points. Now, my sheet pile, I'm going to just show you what it looks like in Revit before we go any further. So inside Revit here, we'll go and find my family that I'm hoping to insert in here. Here it is, and let's just edit that. And what it is, it's a structural pile, sheet metal pile, that's actually nested into an adaptive family. So if we go and take a look at our floor plan in here, you'll see that I've just got two adaptive points. So what I want is Dynamo to generate these pairs of points to insert these sheet piles on. That's the thought process behind this. Okay, so in order to do that, let's go back into Dynamo. So I actually need a point every 900 units, but actually it's a little bit more than that. I need to essentially have double the points, so it puts 0.1, 0.2, then 0.1 over 0.2 and so on. You'll see in a minute. So what we need to do is first create a bit of a calculation. Now, in actual fact, what I'm looking for here is a formula. I want to use a code block. Now, to create a code block, you're essentially just double clicking in the background of Dynamo. And what I want to do here is I want to type in curve length divided by, what do I want to do here? Pile length. In fact, I'm going to change that. I'm just going to call that pile size. Now you'll notice I'm using camel case here, not using any spaces and so on. And in my code block, it's now asking for the curve length input and a pile size input. Now the pile size is 900. So I'm going to use a code block to put in 900. And now I want to divide that by 2. So I can basically say A divided by B or whatever I want for that. Yep. So it's the length divided by 2 gives me an output in there. If I run it, of course, of 450. That can go into my pile size. So my curve length is basically this here. And now if I run that, you can now see that Dynamo has created or worked out the number of points that I need, 98.126. Now, of course, I don't want an integer there. I want a whole, I want an integer there. I don't want a real number. So I'm going to round it down. So in Dynamo, that's called a floor calculation. So we can just type in floor, math.floor, and we can take the output of this node into the input, run that, and there's 98 points. So we can now wire that into the number, run, and if I zoom into some geometry now, can you now see that we have all of those points? Yeah. Those same points will also preview inside Revit as well. So if we just switch into Revit itself, you can now see it's generated all those points along that curve following the topo. Right, so now we're almost there. What we now need to do is just have a look at the structure of these points. So once again, I'm going to use a watch window just to see what we've got. Again, you mustn't forget to run this every time now. Okay, that looks good. So we've got a nice clean list of points in there. If we didn't, we would actually have to flatten that first. Okay. Now, we actually need pairs of points. What we can do here is we can use a function called list chop. Yeah. Very simple tool. So we take that list and then we tell it to chop it into groups of 2. And if I run that, here are my outputs. Excellent. Right. So now, last thing, we need to actually get Dynamo to actually place down the content itself. So the first thing I want to do is place an adaptive component by points. Now, there's not too many adaptive component tools in Dynamo, but you can see I've got one here for points. So obviously, the list of points will go into there. The next thing I need is to be able to tell it what family to insert. So that's family types. And again, we can just type in family types in here. And this is quite interesting. This is a drop-down list, and it basically just targets everything in my project. Yeah. Now, my pile was called ZU900, so fortunately it's the last one in the list. If you are looking for something, you can just type in the letter zone. You can see it zooms to those quite easily. So that's that. So we'll now load that in there. And finally, we should be able to run. Okay. So we've got a yellow node in there, and I'll explain that in a minute, but you can now see the outcome inside Revit. So you'll notice we've got an absolutely perfect layout of piles in here. Obviously they're all individual elements, so you can schedule them if you really wanted to. You could put coordinates in and so on. You can see that I can change the pile depth from there, and also I can change what I've called the projection above the ground. So if I wanted those to project out 900 above the topo, again we can just change that quite easily. And there we have it. Now, another thing I could have done is I could have actually had the pile depth controlled by this topo surface here, if I wanted to. Perhaps that'll be for another tutorial, perhaps. Yep. Right. So there's our layout. Now, it is completely parametric. So if I make a change to that curve there, and I run it, Dynamo will now obviously reevaluate the problem. Everything will update. So the graph is fully parametric, and we can make changes to the path anytime we like. Okay, and there's my updated sheet piling. Okay, let's just take a look at that in plan, just to see what we've got. Yeah, and there it is there. The blue geometry you're seeing is obviously a result of the Dynamo preview. We can clearly turn that off if we wanted to. So I can just go in here, background previews, and available previews, so we can just switch off the Revit preview there. I'll just get rid of those shadows as well, we don't really need those. Okay, and there's my sheet piling. So pretty useful. Yeah, very good. Okay, hope that's been useful, and I'll be doing another tutorial very soon. Thank you.